So what are we going to learn today? Third-party elevation data sources, usable data forms within Terra software, how to import that data into Terra, the use of LiDAR and drones data versus a surveyed data, how to correct survey data, exporting Terra data, and exporting guidance lines for Gen 3 and Gen 4 displays. Terra Cutter, Ditch, Plane, and Survey allow users to import elevation data from other sources directly into the software. On a side note, for those that you are not aware, we have a new ditching software available called iDitch. It is an easy to learn and use basic ditching software. Straightforward to the point. Survey a drain, the design automatically applies, turn around and implement it. If you would like to know more information, let me know after this webinar. Terra in-cab workflow starts a collection of the elevation data using RTK corrections. Next, design and analysing of the project can be done in-cab, and then implementation of the project with dirt moving equipment. On startup of Terra, on the home screen, you have three options available. First option is to perform the project from the start and collect the data manually. Below that is the import external data function, where third parties accepted formats can be loaded. And at the bottom, load project, is where you can load existing project files saved and also load control files from Terra design. Terra can utilize elevation data files from an external source. Various file formats are supported, which include elevation data collected with drones and LiDAR data collected by aeroplanes. The usable elevation data is broken down into three types. Raw elevation points, which can be imported as a CSV, KML, shapefile, or John Deere adapt log and RCDs. Existing elevation models, which can be imported as a JSON grid, or Trimble field level 2, which is a .xml file, or complete control files, which is our Surface Water Pro ditch tracks, field level 2 .gps files as well. When you choose the import button to load elevation data from an external source, you'll be given the import option types of ditch tracks, survey data, or surface grids. Choosing ditch tracks imports ditch tracks created in Surface Water Pro for use in Terra. Choosing survey data allows import of data collected during other applications. Adapt logs from Gen 4s and RCD logs from 2630s located on the tablet or flash drive can be imported here. You can also import the data collected from other applications located in your John Deere Operations Center account. This data is directly imported with a good internet connection. Choosing survey data will also bring up the options of drains, field, survey, boundaries, and markers, which is where you can import CSV, KML, and shape files, such as those created with data from LiDAR or drones. Field level .xml files can also be loaded through the survey data dialog. Choosing surface grids is where you can import existing data elevation model files, such as .gps files from Trimble field level 2. Now is a few examples of how to load those different file types. So if we're importing from a green star display, either a Gen 3 or Gen 4 adapt log, select the import tab. In this instance, it is a 2630 RCD file required. The load window will appear where you can search for the selected RCD folder. Once selected, the new window will appear where you can select the application task on which the required field to import the elevation from. Once loaded, you can then edit the survey points and then create a surface for the design. Here is an example of loading elevation data from your John Deere Operations Center. First, choose Import, then Survey Data, then My John Deere Operations. You will be redirected to log into your My John Deere Operations Centre account. Use your enter name, then password. It is recommended that you have reliable internet connection. Once you've successfully logged in, a list of your organisations will load. We provide field filters to assist in quickly finding what you're looking for. Pick an organisation, then a field, and then an operation. Choose import and the field will load directly into Terra in-cab software. Elevation data files collected with drones and LiDAR can be imported as CSV files to Terra. Before using LiDAR data, check the date it was collected. Your supplier of the data can provide that information. Drone and LiDAR data usually contains an excessive amount of points. Ask them to export the data down to a manageable amount of points so that not to cause long progressing times. Also, ask the supplier to export the file as a generic text or CSV file. When loading these files, click on the Drains, Survey, Boundaries and Markers tab and select the file for importing. Then choose the surface type from the drop-down tab. Both LiDAR and drone data can take some time to create the surface from the import due to the amount of recorded points within the survey. Here we have sped up the video as it previously took 2 minutes to surface. As we zoom in, you can see here how many points there are in comparison to a vehicle survey. What appears to be already a surface in the collection screen is just the raw elevation points. We are seeing more and more elevation data acquired with drones. Drone surveys can be beneficial when areas cannot be surveyed on the ground, such as waterlogged areas or ditch bottoms. This can result in a more accurate elevation map by capturing all changes in elevation as its pass-to-pass swath is closer over a ground survey, which can result in a large difference in dirt balance totals. But the drone elevation needs to be edited down to a manageable size in order not to overload the Terra software system. Ask providers for the point spacings to be between 7 to 10 feet upon export. The more points, the larger the file size and longer the processing time. Large files can be handled well in Terra Design, but can cause delays and lags if imported as a raw elevation map or control file for implementation in the in-cab software packages. Here we are importing drone captured elevation data into Terracotta. First, use the Import tab, then the Drains, Field Survey, Boundaries and Markers tab. Select the correct CSV file to be imported. During the import, you will be asked to select the type of elevation data that is in the file, field or drain, and using units of measurement. Once imported, you can then edit the elevation points in the collection tool before a ground surface will be generated. From there, you can commence designing. Moving on to loading a field level 2.gps file. Select the import, surface grid, then field level 2 tab. Select the .gps file that you want to use and click open. Once it has imported, the design surface will be attached to the project, where you can apply a design or you can use as a control file for implementation if a design has been already created. When exporting a control file from Terra Design for use in Terra in-cab software, it is important to understand the data to be exported depending on the intended application. The minimum layers that you will need to drag into the export window would be an original elevation surface, along with the design and any benchmark points needed to reference the compiled design in field when implementing. This export creates a .tci file for the use in Terracotta as a default. Once a control file has been created in Terra Design, you can then import via the Load Projects tab. Click on the Find Manually tab, locate the .tci file from the selected folder. Once loaded, then you can proceed to the Apply tab to start implementing. Correcting the elevation data. Inline Offset is a surfacing tool that assists in making corrections to elevation data that is imported from other sources. that looks torn or pulled apart in direction of travel. To access this tool, press the Fix Lag button located at the bottom left of the tools at the bottom of the screen. Pressing this button will open a pop-up window that will provide you with the options to correct elevation alignment. When correcting elevation data, there are two separate sections: shift distance and path separation. To control how far the data is shifted, you can either use the slider or manually set the distance. The path separation is the distance between your points moving forward before it is considered to be a new segment. When making changes to the data in the inline offset window, the changes will be reflected on the surface in the background. This will help to make sure that the changes you're making are correct before accepting them. Sometimes the elevation data imported from third-party sources requires editing. It is best to check the data in the surface step before creating a project. There you are able to delete points if needed that are outside the field, not wanted in the design surface, or have a corrupt elevation point recorded. This area is found usually when the surface will be all one color due to a random bad elevation point, causing the surface to have a large variable elevation scale. Remember that if these unwanted elevation points are used in your surface, the dirt balance will include them, resulting in inaccurate totals. To remove these points, you can either crop them together in a circle or highlight in a line. Once highlighted, click on the eraser to remove the points. If you make a mistake when editing the points, just exit the surfacing page and click No to keep changes of elevation points. Re-enter the surfacing tool and the original surface will be present again. After editing the elevation data and creating a surface, you can then choose what design tool you require for a full field or drain design. One of the tools in the design functions allows users to separate the fields into regions and to create individual designs for each region to minimize haul distance and lower total dirt balances. Once complete, you can then check your design in the rainfall simulator. When using Terra software, you are able to switch to a 3D view of the map. You can use a vertical scale magnifier to increase the exaggeration of the hills and valleys so that you can be more easily identified. Also, one of the many unique features of the Terra products suite is our inclusion of a rainfall simulation tool. This allows a very visual and easy, relatable analysis of how a field surface affects water runoff and ponding. Importing elevation data from the John Deere Operations Center or other third-party sources, and then using our tool for analyzing of the field's current water flow and terrain is a great way to understand where the problem areas are within the field and make a plan to fix them. Always remember to save your project as you progress through this from survey to implementation. When the Save tab is pressed, a window will open that allows you to save to a specific project name. It presents you with a screen to save using structured files. You can add grower, farm, and field names. Click on the Manually Choose Location tab in the lower left if you're wanting to save your .tci project file to a different folder or USB stick for storage or transfer. When exporting raw data points from Terra, field and drain survey data will be exported as a CSV file. Boundary survey data will be exported as a KML file. Clicking on the Export tab in the Collection homepage will open the File Explorer tab. There you can select a folder or USB to export the data to. If you're wanting to export a project file .tci of the elevation surface, the Export button is located in the surfacing homepage. These will also be exported via the File Explorer to a location of your choice. You also have the option to export the surface as a .agps file. Markers created in Terra can now be exported to your Gen 3 display as a flag for points of interest. If you choose the export button, a window will open that allows you to save to a specific field. It presents you with a screen to save using structured files. You can add farm, field name, and field name. Yes. You can also choose a previously saved value in any of these fields from the drop-down list. It needs to match what you have set up in My John Deere. Once a marker has been created, an export button will be available on the menu page. By clicking on the button, you will then be able to choose between a CSV file or an RCD file. By clicking on the RCD file, you will then enter the correct details. To load them in your guidance screen, insert the USB, import data, and the flags will be attached to that field that was saved as a marker in the Terra. If your design includes a drain or levee, once you have finished designing your drains and levees and you're happy with them, you can export these paths as guidance lines. Export begins by pressing the export button next to the information of the data presented at the bottom of the design home screen. This allows you to save the levee or drain lines as guidance curves for the use in John Deere AutoTrack. If you choose the export button, a window will open that allows you to save to the specific field area. It presents you with a screen to save using structured files. Again, you will enter the client, farm name, and field name and project name. You can also choose a previously saved value in any of the fields from a drop-down list. It needs to match what you have set up in My John Deere. Ensure a curve type is set to adaptive curve so that you'll be able to see all the levee lines at once. Set the display to the model number of the John Deere display you are using. When saving for use in a Gen 4 display, choose 2630. Press export and the file with your guidance lines will be prepared for you to save at a chosen location on the hard drive. You can then copy to a flash drive. These are the steps to transfer guidance lines to a 2630 display. Insert the USB drive with the guidance lines into the saved onto the John Deere Green Star display. Automatically detect the USB and show the options available. Select the import guidance lines, which should be at the bottom option. Select the desired profile and press Begin Transfer. On this screen, select which client, farm, field, and tracking option of the file you want to import and press Accept. The tracking option should be set to adaptive curves. Make sure the correct lines you want to import are chosen and press Accept. A loading bar should appear. If everything has been successful, the Data Transfer Complete screen should appear and you'll be able to press Accept. Your guidance lines have been imported into your John Deere Green Star display and are now ready to be used with AutoTrack. Remember to check the repeat box. Transferring guidance lines into a Gen 4 display can be accomplished with the following steps. Connect a USB to the screen or server. It will automatically populate the USB option. This will then transfer you to the File Manager app. Select Import from USB. Select the folder type. Select the data type guidance lines and set up data. Once the import is successful, you will be able to load the guidance lines by first loading the correct client, farm, field. Then the guidance lines will be available in the Set Track tab on the guidance screen. Terra in-cab programs have great built-in and up-to-date resources for understanding the software's functionality and troubleshooting, with a quick start guide and operator's manual links on the homepage. Make sure when you are updating your Terra software to check to see the latest versions of these are downloaded to your tablet. A banner across the tabs will let you know when there is a new update available. We have many resources available for Terra owners. Our YouTube channel, manuals, and webinar recordings. We also like to keep everyone informed through Twitter, Facebook, and Instagram.